Okay, so it's quite nice when we're given graphs to solve simultaneous equations. And that's because the easiest way to solve it is actually just to identify the point of intersection. So in this case, our point of intersection is going to be x equals -1, y equals 3. And that's it, which is why it's worth one mark. Sorry. Alright, now for this one we've got something a little more complicated. So I'm going to do this on the whiteboard here. So I have the question, let's get my cursor here, so 2x plus 3y equals 31, and 3x plus 6y equals 57. Now, remember when you're solving, as long as it doesn't tell you that you have to solve either by substitution or elimination, it's just whatever one is easiest. So in this case, actually, elimination is going to be our easiest method because I've got a 3y and a 6y. So what I'm going to do is I'm going to take this first equation here, I'm going to multiply the whole thing by 2, okay, and I'm going to subtract it from my second equation, or my second equation, which has now become my first equation. So that's going to leave me with 4x plus 6y equals 62. And I'm subtracting it so that those two 6y's don't cancel out to 0. Okay? So 3x minus 4x is going to give us minus x. 57 minus 62 is going to give us minus 5. So that leaves us with x equals 5. And all I've done there is divided by minus 1. Now, once I have my x value, my next thing I need to do is solve for y. So I'm going to go back to my original equation. So I've got 2x plus 3y equals 31. Those numbers are just a little nicer, so I'm going to use those. So I'm going to plug in my x value, which is going to be 5. So anywhere I see that x, I'm plugging in the value of 5 instead. Sorry. So I have 2 times 5 plus 3y equals 31. That gives me 10 plus 3y equals 31. I'm going to subtract 10 from both sides. 3y equals 21. Divide by 3. Divide by 3. Y equals 7. Okay, so x is going to equal 5. Y equals 7. Alright. And I can put those values in. Now, the next one, so if we look at this one, this would be an example where actually substitution might work quite well. So let's go through and do that by substitution. So I've got x plus y equals 4 and y equals 2x plus 10. Clear this off. So x plus y equals 4 and y equals 2x plus 10. Now, if I look, I've already got one variable that's defined in terms of the other. So what I can do is I can look at my original equation and I can put it all in terms of x. So anywhere I see that y, instead of putting in y, I'm going to put in 2x plus 10. So just like that, and that's going to equal 4. So then I'm going to combine my terms just like I would any other equation. So I've got 3x plus 10 equals 4. I'm going to subtract 10 from both sides. 3x equals minus 6. Divide both sides by 3. X equals minus 2. Now, once I've done that, I need to again plug in. So that gives me 2 times minus 2 plus 10. That equals minus 4 plus 10. Equals 6. So y equals 6 and x equals 2, y equals 6. Alright, and again, it doesn't matter which method you're using as long as it hasn't specifically told you to solve one way or another. It's just which way is going to make your life easier. And we'll do one more here. This one's a little bit trickier. The numbers aren't as nice, so we've got up here, I'm just trying to get my cursor back here, 4x plus 7y equals 68, and 9x minus 2y equals 11. Now for this one, the easiest way to do it is actually just to cancel out my y's. I'm going to do that because I've got a minus and a plus, which means I can add the two together. Now, to get a common factor, I'm just going to multiply the bottom one by 7 and the top one by 2, and those are going to cancel out my terms. So I'm going to rewrite them over here. I'm going to be left with 8x plus 14y equals 136. And I'm going to have 63x minus 14y equals 77. And again, I'm going to add those two because that's going to cancel out my y terms. That's going to leave me with 71x equals 213. I'm going to divide both sides by 71. And x is going to leave me with a nice clean value of 3. And I mean that by saying I don't have any decimals, I don't have any recurring decimals, there's no weird looking fractions, all of which are possible, but it tends to be that these are a little bit nicer. So from there, I'm going to look back to my original equation and I'm going to solve for my y value. So I'm going to use the bottom one. Let's use 9 times 3, which is my x value, so I'm just plugging in for x, minus 2y equals 11. So 27 minus 2y equals 11, minus 27 from both sides, minus 2y equals minus 16, divide both sides by negative 2, and y leaves me with a value of 8. So I have x equals 3, y equals 8. And I hope that that has helped in terms of how to solve simultaneous equations.